In this video, we're going to look at solving trig equations that involve tan. So there's generally two types of equations, one that actually says tan, and the other sort where you need to use tan of theta is sine theta over cos theta to be able to solve the equation. So let's start with the first one. The process that we use for solving tan equations is exactly the same as the process we use for solving equations with sine and cos, and that is writing the equation first of all so that it's just tan of something is equal to something else. And in this case, if we add 1 and we divide by root 3, we get tan of x is 1 on root 3. So then we need to think about the quadrants that we're operating in. So 1 on root 3 is a positive number, so we're up this end of the tangent line, and so we are working in the first quadrant to give us a positive number and the third quadrant. And so the next thing we need to do is to check our reference angle. So in the first quadrant, the angle that gives us 1 on root 3 is pi. And now we need to check that our domain is matching our angle, which it is. So now we can just simply start to generate our solution. So we're going to work our way through the domain. I'm actually going to start at 0 and work backwards, which means our first angle that we're going to come across, which is this one down here, is minus 5 pi on 6. And if we work in the opposite direction from 0 to pi, we pass this angle here, which is pi on 6. And that's completed our domain. So these are our two solutions. So we're going to have a look at this equation. Sine of 3x equals 2 cos of 3x. For two reasons. One, you can write sine of 3x divided by cos of 3x as tan of 3x, but also because I want you to recognise that this is in fact the graph of the sine curve, which is the green curve in the picture that I've got below, and the graph of the red graph, which is the cos curve, 2 cos x. It's actually asking you where those two graphs are equal. So we're actually looking for the intersection of these two graphs in a particular domain, of course. And so, as I mentioned before, we can take the sine of 3x and the cos of 3x, and because they are of the same angle, I'm going to divide both sides by cos of 3x, and that will allow me to write it as tan of 3x is equal to 2. Now, if this was a number that was one of our exact values from tan, we could continue on and solve it by hand if we wanted to. But because this question actually asks us to give our answers to a particular number of decimal places, if I was doing this in the exam, I wouldn't do any of this at all. I would just put the formula straight into the calculator and ask it to solve it for me. In this question, we're going to find a minimum value of k, correct to 4 decimal places, so we're going to be using our CAS calculator, so that sine of pi x is equal to k of cos of pi x. So you can see here this is set up. The angle that we're working with is the same. We've got sine on one side, cos of the other, and so it's set up to become tan of x, tan of pi x, which is why it's here. But what we're looking for is these two functions to have no solution over the domain 0 to 2 pi. So let me just tidy this up for you. So if we divide both sides by cos of pi x, we get sine of pi x over cos of pi x, which gives us tan of pi x is equal to k. Now, in terms of being able to solve this, we need to think of we need to think of this equation here as actually being two graphs themselves. So this will be y is equal to tan pi of x, and this one will be y is equal to some number k. And what we're going to look for, the fact that it says that they're equal to each other means that we're looking for points of intersection. And at a point of intersection, you have what's called a solution to the equation. So what we're after in the question, we're going to have no solution over the domain if there's no point of intersection. So we need no intersection points to have no solution, and we need no intersection points over the domain 0 to 0.2. So on our graph, we're going to look at the section from 0 to 0.2. We're going to look in this section in here, and what we need is no point of intersection in that space between the two lines. So let's get our CAS calculator out and have a look. So here's the screen from the calculator, and I've screen recorded what needs to be done on my PC. You can see I've used Screencastify to do it. And so you can see that I'm using the older version of the CAS here. If you've got the one with the blue stripes and the different colour thing, you'll notice that on the screen of yours, you don't have this settings button here. So I'm going to use that in a minute. But you can access this pretty much the same settings using your menu button. So let's go. So just input the function. And get it to sketch. And I'm going to zoom in because I don't need that whole thing. Now I've set my CAS calculator up so that it actually shows you something here. So to get rid of this, if you click on the settings and go to document settings, down here on the calculation mode, you can see it's exact. If you turn it to auto and press OK, zoom in again, it turns these fractions back to decimals. So my suggestion would be, when you do it, you should be able to just have a look in here. They're not exactly the same thing, but see this make default. When you change it to auto, press the make default and then make it as your default setting. Okay, so let's just zoom in again. All right, so now I'm going to put in y is equal to k, and it's going to make a slider for me. And here's my slider here. So to operate the slider, you can move it around and drag it down wherever you like. But to operate the slider, you press on the click and hold, and the little fingers close, and then you can use the left and right arrows to move it left and right. So down is not going to shift it, but using the left and right arrows, I just bumped it on my keyboard, will move it left and right. And what that will do, it'll change the value for our second function, which is y is equal to k. And when you do that, it'll move it up and down. So the k values at the minute are set to go from a minimum value of k as -5 to a maximum k value of 2. And the step is automatically going up by 1 each time you press across. So I've just changed it so that it's smaller. You can see -2 and 2. And then when I click and grab, I'm just going to press and hold on the center. It's grabbed it. And now you can see over here, I'm clicking left and right, and it's just shifting it up. There's the k value there, up and down by 0.1. And you can see that that line is going up and down. And so what I need to do is I need to make sure that the lines are intersecting between 0 and 0.2. So I'm putting in x is equal to 0.2. So in the function, I pressed the backspace button to get rid of the equals, and it asked me for a relation. And here's my line, x is equal to 2. And now I can grab my k value, click and hold to grab the k, no, wrong thing. Make sure you're over the, slider when you click and grab, and you can see that I'm moving it up and down. So what we need is just one intersection point between the line and our tan line. And so what we're looking for, you'll get one solution in this point all the way up to where our tan line crosses this x is equal to 0.2. So what I'm trying to do here is find the intersection point. So my calculator is set up to give you at least, 6 decimal points. Now if yours is only showing 3, you can go back in through your document settings and change your float here to float 6 or to float. And then my suggestion would be float 6, make it say OK, and then you'll get 6 decimal places here. And so I'll just pause that there if I can. It's still going. And so you can see that the minimum value that our k needs to be, our k value needs to be bigger than 0.726 to be above that line. And so anything below that level, let me give the line here, anything below here is going to intersect along this bit. So our minimum k value, we need k to be greater than or equal to, actually we need k to be greater than, for no solutions, we need k to be greater than 0. So we need 4 decimal places here. So our last decimal place is a 4, so that's fine, 0.7265. And that's the answer that we need for the question that was asked on the previous page. That's our minimum value of k, so that the two functions have no intersection between 0 and 0.2. So that section there